Hello students, welcome to another video, that is the second video of application of derivatives. So in this video we shall discuss a few problems from the exercise 6.2, that is of increasing and decreasing functions. So let us see question number 6. See, here this is a function given and we need to find the intervals where this function is strictly increasing and strictly decreasing. So for that, let us consider f of x is equal to minus twice x cube minus 9x squared minus 12x plus 1. So how to do it? At first, take the first derivative, that is f dash x. So it will be minus 6x squared minus 18x minus 12. So I can write it minus 6 taking common. So this will be x squared plus 3x plus 2. Fine. Now what to do? Let f dash x is equal to 0. Equate this equal to 0. Then we shall have minus 6 into x squared plus thrice x plus 2 will be 0. So this will give us x squared plus thrice x plus 2 is equal to 0. If you solve it by midterm factorization, we shall have x squared plus 2x plus x plus 2 is equal to 0. This will give us x plus 2 plus 1x plus 2 is equal to 0, and hence we shall have x is equal to, or let me write x plus 2 into x plus 1 is equal to 0, and we shall have finally have x is equal to minus 2 and minus 1. Clear? That means these 2 points will divide the real number line into 3 parts. Let us see, if this is our real number line that is going from minus infinity to plus infinity, here we have 0. So what is the point we have? X minus 2. So minus 2 comes first. In the left hand side this is minus 2, and suppose this is minus 1. So these 2 points, x is equal to minus 2 and minus 1, divides the real number line into 3 parts. Fine. So we have therefore 3 new intervals. What are the intervals we have? Minus infinity, minus 2, these are disjoint, minus 2, minus 1 and minus 1 plus infinity. So now let us check the increasing or decreasing functions, whether the function is increasing or decreasing in each of these intervals. So for the first case, okay, what was our f dash x? F dash x was minus 6x squared minus 18x minus 12. Fine. So in the interval minus infinity comma 2 and minus 1 comma infinity, what we see is that x here, x is less than minus 2, because if we consider this interval, whatever x we take there, x will be less than minus 2, and here x is greater than minus 1, isn't it? So what about f dash x? Therefore f dash x will be, so since our f dash x is what? If I take here this is our 6, if I take here minus 6x squared plus 3x plus 2, so this will give us minus 6 into x plus 2 x plus 1. Let's factorize this, because our roots were minus 2 and 1, so it will be x plus 2 and x plus 1. Fine. Now this is our f dash x. Clearly in this interval, consider for this interval, here x is less than minus 2. So whatever x you take less than minus 2, so what we shall have? We shall have minus 3, minus 4. So if you put here minus 3, this will be what? Minus 3 plus 2 will be negative. This here also, if you put minus 3 or minus 2.5, this will also be negative. So negative into negative will be positive. Negative into negative will be positive, and also here you have another negative, so this will be finally negative, isn't it? So for this part, this will be negative. Again, for x greater than minus 1, if x is greater than minus 1, then it will be at least minus 0.5. If it is minus 0.5, then 2 minus 0.5 will be 1.5 into 1 plus 0.1 minus 0.5 will be 0.5. So both are positive, and here it is negative. So negative into positive plus positive, and whatever else value you take here, x equal to 0, 1, 2, 3 and so on, in the positive direction, you will get this part positive. So positive into negative will be again negative, isn't it? So for these two intervals, our f dash x is always less than 0, and hence we can say that therefore f is decreasing. F is strictly decreasing on the intervals where minus infinity comma minus 2 and minus 1 comma infinity. So these two parts are done. Now these two parts are done, we are remaining with this. So now let us check it for minus 2 and minus 1. So in the interval minus 2 comma minus 1, what is happening here? X is greater than minus 2 and less than minus 1. That means the value of x is always negative. So since the value of x is always negative, so f dash x will be, f dash x is equal to what? It is minus 6 x plus 2 x plus 1. So if you consider a number that is less than minus 1, if it is less than minus 1, so it will be something like minus 1.5. So this part will be negative. So, and if you consider a number, okay, and whatever number you take here, since it is greater than minus 2, so this will be positive always, isn't it? So positive into negative will give us positive, and hence we can say that this is greater than 0. So it is, so therefore f is strictly increasing for, or on the interval what, minus 2 comma minus 1. Fine. So this is how we find the intervals. And next let us proceed to another problem. So now let us see another problem, that is question number 7. Here they have given a function y is equal to log of 1 plus x minus twice x by 2 plus 6, and x is greater than minus 1. So we need to show that this function is increasing throughout its domain. At first, what is its domain? Here they have considered all the real numbers that is greater than minus 1. So its domain will be minus 1 greater than minus 1, so open interval minus 1 to infinity, and infinity is always written with an open interval. Okay, so here y is log of 1 plus x minus twice x by 2 plus x. Fine. And just write where x belongs to this, and therefore dy by dx will be 1 by 1 plus x minus derivative square into derivative of first function, that is 2, minus derivative of second function, so it will be 1. So here we shall have 1 plus x, keep it same, this will be 4 plus twice x minus twice x. You can cancel out this 2. In the next line, take LCM, 1 plus x, 2 plus x whole square, this will go up, 2 plus x whole square minus 4 into 1 plus x. Now what will be this? Just break it, 4 plus 4x plus x square minus 4 plus, minus 4x. So, and in the denominator we shall have 1 plus x and 2 plus x square. Fine. Now 4x and 4x can cancel here, 4 cancelled, so we shall have x square divided by 1 plus x 2 plus x whole square. So this is our f dash x or ddx of y. Now to find an interval or to show that it is an increasing function, what do we need to do? At first take dy by dx is equal to 0. So from there we shall get the value of x and then divide the or split the interval, and then we shall check for f dash x is greater than 0 or less than 0. So dy by dx equal to 0 means x square by 1 plus x and here 2 plus x whole square will be equal to 0, and this will give us x square is equal to 0, and from here we shall get x is equal to 0. So x is equal to 0 splits this particular interval into two parts. So now we shall have the two new intervals, that will be -1 comma 0 and 0 comma open interval 0 comma infinity. So you have got these two intervals. So let us check the increasing and decreasing in these two intervals. So let x belongs to, or just write for at -1 comma 0. Let us see what happens at -1 comma 0. X belongs to -1 comma 0 implies x is greater than -1 and less than 0, isn't it? So for this value, what happens with the f dash x? What is our f dash x? It is x square plus 1 plus x and 2 plus x whole square. Fine. So here, since x is less than 0, that means x is negative. Since x is negative, so x square will be, since x is negative, so negative square will be positive. So this will be a positive quantity. Again, x is negative, but x is greater than -1. So 1 plus -1 into something, so this will be a positive quantity, because this will be like -0.9 and something like that. So this will be a positive quantity. So positive into, again, whatever value we get here, suppose x is greater than -1, so let it be x is -0.5 or -0.1. so whatever value you put here, add it with 2, it will be a positive quantity, and if you again take the square of that, it will be again the positive quantity. So this will be positive. So positive divided by positive into positive will be positive, and so that will be greater than 0. Fine. So therefore f is increasing on the interval -1 0. Clear? Again, see, we could have written as strictly increasing, but since the given interval is open itself, so no question of that. Again, at what is our new another interval? It is 0 comma infinity. So that means the whole positive real number line, f dash x is equal to x square 1 plus x whole 2 plus x whole square. Now whatever x you take here, if you take any x here, so x will be what? It will be less than infinity and greater than 0. So in other words, you can just write x is greater than 0, whatever x it may be. So for all x greater than 0, this will be a positive quantity, isn't it? Positive square will be positive quantity. Now 1 plus a positive thing will be again a positive thing. Again 2 plus a positive thing will be positive. Square it, positive. So positive, everything will be positive here. So f dash x will be greater than 0. Therefore f is again increasing on 0 comma infinity. Fine. So thus we have shown that for both of these intervals f is increasing. So therefore throughout the interval Therefore f is an increasing function, throughout its domain. Clear? So a very important question, please go through it. So here the next problem we have is question number 14. That is, find the least value of a such that the function f given by fx is equal to x square plus ax plus 1 is strictly increasing on the closed interval 1 2. So let us see. Here the function is f of x is equal to x square plus ax plus 1. So therefore what is our f dash x? It will be twice x plus a. Fine. Now here given is that the function is strictly increasing. So when a function is strictly increasing, here f of x is strictly increasing for f dash x greater than 0 whenever x belongs to the open interval 1 comma 2. Therefore f dash x greater than 0. So this will imply, what is our f dash x? It is twice x plus a greater than 0 for x belongs to the open interval 1 comma 2. So from here we get twice x is greater than minus a for x belongs to 1 comma 2, and this gives us x is greater than minus a by 2 for x belongs to 1 comma 2. Fine. Now what does this mean? Here I can write x greater than minus a by 2, and this means x is greater than 1 and less than 2. Fine. So from these two relation, what do we need? We need the least value of a, the smallest possible value of a for which this condition holds. So here x is greater than 1, exactly greater than 1, isn't it? And x is also greater than minus a by 2. So what is the possible least value of a by 2? It can be 1 only, isn't it? So the possible value of minus a by 2 will be 1. Therefore for f to be strictly increasing on the interval, which interval? Closed interval 1 2, x must be equal to, minus a by 2 must be equal to 1. Fine. And from here we get a is equal to minus 2. So a equal to minus 2 is the least value of a for which the function fx is strictly increasing over the interval 1 2. So that is our question number 14, and I have done several problems in the notes, as well as I have explained a few things in the PPT. So please go through them, and if you have any doubt, please feel free to contact me anytime. So till then, stay home and stay safe. Thank you.